For this class, we'll continue where we had left off there on Tuesday, where we were describing the motion of different displacement graphs. So we had finished last class with this example here. And now the next question, you're asked to describe the motion of the graph shown below. This is a displacement time graph, and the object or the directions we're given here is that this one is moving here at the right, and below your x-axis there will be to the left. Now, to describe the motion, what I would like you to do first is make a couple of jot points on your page, so please pause the video. Okay, now let's assume that you have that done. And the first thing you may want to say is that the object starts 7 meters right of the reference point. So again, here will be our reference point. And if you count off, you have 5, 6, so you're starting 7 meters away from the reference point. The object then moves to the left. So it hasn't continued to move further away. It's moving back towards the left. It does so for, if you count off the time, it does this for 6 seconds, which is given here. That's when the motion makes a change. And you should probably also include the velocity. And remember, the velocity is the slope of the line. So if you would look at your rise, so here you're rising, if we count down, it's 7 to 0, 8, 9, 10, 11, over 6, that's 5, 6, so just and then very quickly 11 divided by 6, your rise over your run, and 1.83. Or 1.8. Okay, next, you see that the object stopped for 4 meters and it's left of the reference point. So here, it stopped 4 meters away, and how long does it stop for? If you count off the time, 1, 2, 3, 4 seconds. After that, the object then moves back to the right, and it moves to the right for 1, 2, 3 seconds, and its velocity again, or slope of the line. You want to look at your rise over your run. So it would rise 1, 2, 3, 4, 5, 6, 6 over 3, or 2 meters per second. And then, lastly, the object stops at 2 meters to the right, and it stopped for 2 seconds. Now, for the next question, you're asked to sketch a graph to match each of the items listed there. So this is going to describe the motion of the object, and I want you to end up doing the graph. So again, pause the video, and then we'll start it from there. Okay, let's go through each of these now point by point. So object starts 6 meters to the right of the reference point. So you were told from last class, if we just go back through the notes, that to the right is considered positive. So if you look at that here, the right is considered the positive direction. this here. And 6 meters, so we should be able to fit 6 on here. 1, 2, 3, 4, 5, 6, and that's right here. So the object starts 6 meters to the right of the reference point. It moves with a constant velocity of 3 meters per second for 3 seconds. So we know at the 3-second point, 1, 2, 3, so this will be 3 seconds, that's going to travel for 3 seconds at 3 meters per second. Now remember, 3 meters per second is the slope, or 3 over 1. So again, hint here, what is the slope? Well, it's 3 over 1. And it's moving to the left. So you go down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. And down 3 more. 1, 2, 3 over 1. Okay, and you're told that the object now stopped for 5 seconds. So 1, 2, 3, 4, 5. So we've done this one and this one. Now the object moves a uniform motion at 2 meters per second to the right for 4 seconds. Again, it asks what's the slope? Well, the slope is 2 over 1. So up 2 over 1. Up 2. Oops, up 2 over 1. So you move for 1, 2, 3 seconds, and here's 4. And then the object stops for 2 seconds. There you are. Now, if this were a test or assignment, I'd ask that you use a ruler. Just make sure you keep everything neat and orderly. Alright, a couple more questions. So sketch a graph to match the following motion. So again, pause the video and then go through and produce the graph after. So now let's assume that you've already went through this. So an object starts 8 meters per second south of the reference point. And if you recall, north is positive. So everything above this line will be north and positive. Everything below the line is south and considered negative. So it starts 8 meters away. 1, 2, 3, 4, 5, 6, 7, 8. So the object starts here and then moves with uniform motion with a velocity of 2 meters per second. So the slope is 2 over 1. So up 2 over 1. And you continue the slope. And it's going to do this for 6 seconds. So 1, 2, 3, 4, 5, 6, so up until we get here. All the points should line up because you're told it moves with uniform motion. Oops, don't mean to cross that out, but it moves with uniform motion. It stops for 4 seconds. So 1, 2, 3, 4. And moves with uniform motion, a velocity 3 meters per second south. So 3 over 1. So down 3 because it's moving south over 1. Down 3 over 1. Down 3 over 1. and then it stops for 3 seconds. Well, we can show 2 seconds here. Example 6, describe the motion shown below. So again, take a moment and do that question on your own, then we'll come back to it. Okay. So, you went through it and done it yourself. First thing to look here, the object is east. If we consider velocity, the velocity is constant. If you look at what the velocity actually is, it's 6 here, so 6 meters per second, and it holds that velocity for 5, 6, 7, 8 seconds. So the object moves at 6 meters per second for 8 seconds, and moves to the east. Looking back here now, the velocity of the object, and again this is a velocity time graph, so very careful to read your axis. Velocity immediately drops to 0, so velocity drops to 0 means it stopped, and it stopped for 1, 2, 3 seconds. And after that, the velocity becomes negative, and it's -4, which means it's moving west, and it's doing so for 1, 2, 3, 4 seconds. So it moves west at 4 meters per second for 4 seconds. Okay, last question on this section here. Sketch a graph to match the following motion. The object starts with an initial velocity of 8 meters per second left, then moves with a constant velocity of 8 meters per second left for 8 seconds, stops for 2 seconds, and then it moves at a constant velocity of 8 meters per second to the right for 4 seconds. So you can take a moment to finish that. Okay, before we get into too far on this question, I do make a small change. That should be displacement, should be velocity. And that's in meters per second. So the object starts with an initial velocity of 8 meters per second to the left. So that will be here, because left is considered negative. And 1, 2, 3, 4, 5, 6, 7, 8. So the object starts there. Object moves with a constant velocity of 8 meters per second to the left for 8 seconds. So the velocity doesn't change for the next 8 seconds. So 1, 2, 3, 4, 5, 6, 7, 8. So that takes care of these 2 points. We just need to connect them. It then stops for 2 seconds. So if it stops for 2 seconds, the velocity at this time now becomes 0. And then moves at a constant velocity of 4 meters per second to the right. So 1, 2, 3, 4, and does this for 4 seconds.